This is 5.2, probability distributions of a discrete random variable. So last one we talked about continuous versus discrete. Notice we are specifically looking at only discrete now. And we're looking at probability distributions. So obviously we're going to be dealing with probabilities. So example 1, probability, flip 2 coins, how many tails? Okay. So just to look at it, all the outcomes. Flip 2 coins. So there's my first coin. This represents my second coin. Regardless of what I get in my first, I can get heads or tails on the second. So I have heads, 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 tails, tails, heads, tails, tails. Okay? So we have to actually answer the question, though. How many tails? So we have to look at the different random variables. Remember, they are numbers that represent whatever we're looking for. So if x is the number of tails, look at each outcome. So this one has 0 tails. Both of these have 1 tails, and this one has 2 tails. So the values of x that I could have are 0, 1, or 2 with coin flips, right? 0 tails when I get heads on both coins, 1 tails when I get 1 tails and 1 heads, and then 2 tails when I get tails on both coins. Okay. The interesting thing is, notice when we're thinking about probability, the probability of getting only 1 tails is higher than getting 0 or 2 because there's 2 ways that I can get 1 tails, whereas only 1 way to get 0 or 2. And so how we represent that is with a probability distribution. So this is your new term, and instead of completely defining it right now, like you can look in the book and you can read the definition, we're going to look at an example. So how we do this is we take x, which is our random variable we just defined, as 0, 1, or 2, 0, 1, or 2, and we look at the probability of each of those outcomes. Okay, so this one's a simple one. So first is the probability of getting 0. Okay, so that's the value I'm going to fill in there. So we look, I have 4 outcomes. One of them is that, so 1/4 would be my probability. And then we look at the probability of getting a 1. This says 2 outcomes out of the 4. So that's, well, we simplify, 1/2. And then finally, the last one is 2 tails, which is 1 out of the 4 outcomes. Again, can't simplify, 1 out of 4. Okay. We need to always check the properties. These are very important things. We talked about these. These are 2 laws of probability. The first law of probability, the first property we need to check is that all of our probabilities are between 0 and 1. Everything has to be between 0 and 1. So you can see all of these are fractions that are less than 1 and greater than 0. They're positive, so that means they're greater than 0. They're less than 1, so it works. So that one is checked. We don't have to really show work for that property. Checked. The second property is one we actually have to check. Sum of all outcomes, we'll write that, all outcomes. The probabilities of all the outcomes, when you add them all up, they have to equal 1. Otherwise, you're missing something and you don't have a full probability distribution. We need all of them for this to work. So we add them up. 1/4 plus 2/4 before I simplified, plus 1/4 is 4/4, which is indeed 1. So that one also checks, but that one takes a little bit of work. And so there we have it. We have proven this is a probability distribution because to be a probability distribution, all the probabilities have to be between 0 and 1. And if you add them all up, all the probabilities, it better equal 1. Otherwise, it's not complete. Okay? So there you have it, probability distribution. We also have a histogram that looks kind of like a bar graph. So I guess I'll highlight this. We're not going to spend a lot of time dealing with histograms, but we have a few in this chapter. So all you have to do is you have the probabilities on the y-axis, the different outcomes on the x-axis. Notice that I'm going to plot them apart, and 0 isn't at the end necessarily. I just want to have space for them to all be there. And then on this axis, I have my different probabilities, counting by quarters. And yes, I could simplify, but it makes it easier just to keep it same denominator. So 0 we go a half step to each side, and there we go. 1 half step to each side, that one goes up to 2/4, right? I'm just plotting my probabilities right here. And then finally 2, that one goes up to 1/4. And there's my histogram. Okay, the bars, the height of the bars represents the probability for each outcome, which notice it goes in the middle of the bar. That's how a histogram works. Okay. So we're going to look at dealing with a few different examples now, writing out the probability distribution and histogram with different things, and we'll also talk about the probability function. So consider a modified die. One side has 1 dot, 2 sides have 2 dots, 3 sides have 3 dots. Okay, so there's 6 sides total. 6 sides. We have 1 side that has 1 dot, 2 sides have 2 dots, and 3 sides have 3 dots. Okay. Let x be the number of dots in one roll. Okay, so we need to write out our possible outcomes. 1, 2, or 3. Make a list. It's discrete. You need to make a list whenever you do that. So we will make, it doesn't ask it, but it's the point of this is to make a probability distribution. Okay, so I just have to think about it. This one's actually pretty easy. If I have 1 side with 1 dot, that's a 1/6 chance. 2 sides that have 2 dots, that's a 2/6, which simplifies to 1/3 chance. And 3 sides with 3 dots, so 3/6, which simplifies to 1/2. So 1/6, 1/3, 1/2, or 1/6, 2/6, 3/6 before simplifying. Then we can make our little histogram. Actually, before I do that, I need to check my properties. So I'm not going to write out the properties. I'm going to just call it number 1. Are they all between 0 and 1? Check. Number 2. See, that one doesn't have much work. This one does. I have to add them up. 1/6 plus 2/6 plus 3/6 is 6/6, which is indeed 1. Check. So we always make sure that they add up. Probabilities, x's. So we have 1, 2, and 3. Counting by 1/6. Remember, whenever you make a scale, make sure you count by the same amount. You can't change it because that will change the valuation. So 1/6. Then it's 2/6. And then finally 3/6. And then you have it. That is my histogram for this. Probability functions. Never going to make you write one, but you need to know how to use one. So for this problem, the probability function, P of x, that's the probability, right? P of x represents the probability. So it's basically, if I plug in my x values, how would I get the probabilities out? So if I think, notice the x is the top number, the numerator. And the bottom number for each of these is 6. So if I plugged in 1, so that's 1 dot, right, when I roll the die, I'd have a 1/6 chance. With 2 dots, I'd have a 2/6 chance, and with 3 dots, I have a 3/6 chance. Okay, and so that would be the function that represents it. So you need to know how to plug things in to get it. Okay? Example 3. So we have a normal die now, non-modified normal die. So 1 through 6. I guess that is actually incorrect. It's It's discrete, so it's not 1 through 6. It's 1, 2, 3, 4, 5, 6. Those are my outcomes. Okay. This one seems a little more complicated because when I set up this, I have all sorts of things that I have to write out, right? Because I need to find probabilities for each one. One, 2, 3, 4, 5, 6. And I have a 1/6 chance of getting each one. One of the 6 outcomes is this. Okay, this actually has a special name. We need to check it. Like always, check my 2 properties. First, are all the probabilities between 0 and 1? Yep. Second, do they add up? So 1/6 plus 1/6 plus 1/6 plus 1/6 plus 1/6 makes 6/6, which is indeed 1 checks. Okay, and then we look at the graph. And there's a special name for this kind of graph because of how it looks. So I only need one spot. They are all 1/6. So 1, 2, 3, 4, 5, 6. So notice if I do this correctly, go to 1/6, 1/6, 1/6, 1/6. All of them have the exact same probability, a 1/6 chance. And so it kind of creates this like plateau. Okay? When you see this, this is called uniform or constant. Okay, meaning it is always represented by the same value. And when you have a uniform or constant, you can still have a function. Okay, there's just no x in your function. So x equals 1, 2, 3, 4, 5, or 6, like we already defined. But notice my probability function is just 1/6. No matter what x value, it's a 1/6 chance. Okay, so that's a different type of probability function you might need to read. One where you have to plug in because it has an x. One that does not have an x means no matter what you plug in, that is your probability. So it's telling you they're always the same probability. Okay, so you have your 3-sentence summary.